All right, as we get started today, go ahead and turn in your booklet, in your review exercise and speed drill booklet to page 27, and we're going to be working exercise 32. It's kind of the opposite of what we did in our last exercise, where we were given, here's how much money we have to spend for the month, here are the percentages we want to spend, how much actual money is that? In this exercise, here's the actual amounts we are going to spend in these different categories. So what must be the total amount we're going to spend, and what percentage of that is each of the categories? So we need to first find the total amount we have to spend, the monthly net income as it shows at the top, and then we need to find the percents, which means we're going to have to make some fractions, which turn into decimals, which turn into percents, and then you may notice a pattern that'll save you some time. Joshua did, so pause the video and we'll go over the answers here in just a moment. All right, Joshua, you were the first one to finish the exercise. First of all, what was the monthly net income, Joshua?
$4,000.
$4,000. Now, if you botch the first number, the rest of it's doomed, okay? Did you get the 4,000? All right, so we're good to go there. Joshua, what percent of $4,000 is 520? 13%. What about the mortgage, $920 a month? 23%. $600 a month? 15%. $320 a month? 8%. $360 a month? 9%. And by now we should be noticing a pattern here, Joshua. 320, 8%. 360, 9%. What was kind of the shortcut here? Yeah, if you ignore the 0 at the end and divide by a 4 and stick a percent sign on there, you've got it, right? 32 divided by 4 is 8%. 36 divided by 4 is 9, and 9%. 60 for that matter, going up to food, divided by 4 is 15%. Now, we don't know our 92 divided by 4, but that is 23. 52 divided by 4 is 13. So, Joshua, $280 would be 7%. $160 would be 4%. $480, 12%. $120, 3%, and $240 is 6%. You got them all. Lana, do you see it now that we pointed it out? All right, questions on that? All right, again, kind of a not entirely coincidental. There is good catch. There is a good mathy reason why it works, but once you start noticing what's happening, that's when you can really start to speed up. But I think it took until you get down around utilities and gas to see the shortcut, because now you're dealing with numbers you recognize. And then all of a sudden it's like, oh, I see what's happening here. All right, any questions at all? All right, let me go and collect those from you. And again, real life, you're probably using a spreadsheet to set up your budget. You're probably not doing it by hand. Plus, it's harder to keep track of expenses if you don't have the spreadsheet. But, you know, it's still good to be able to figure out by hand as well. All right, turn in your textbooks, if you would, to page 520. And let's go and take a look at the homework that you did last night. You did numbers 1 through 21 in the homework section, and largely working with like terms and like radicals. Similar radicals. At least some of them were. What makes radicals similar, Lana? Same index, same radicand. In other words, they're perfect, identical matches to each other. And if radicals are similar, you add them. And if they're not similar, you don't add them. All right, so let's go ahead and take a look at that homework very quickly. Excellent. And numbers 1 through 9, you were supposed to simply say yes or no if the radicals were like to each other. Now, in some cases, they may not look like. You may have to simplify first. Let's see how we did on those first 9. Number 1, are they similar, Lana? No, and they don't simplify at all to become similar. How about number 2, Joshua?
No.
Square root of 15 and negative square root of 15 aren't similar? Yeah, they are similar. In fact, they're inverses of each other. If you added them, you get 0, but they are similar. For redemption, Joshua, number 3.
Wait, then what's the answer?
Well, the answer was just yes, they're similar. That's all they wanted on 1 through 9 was yes or no. But the answer would be 0 if you were to add them. Positive 1 square root of 15, negative 1 square root of 15 gives you 0. But we weren't actually being asked to add those. Just
I worked them all out if they were.
If they were, you did. And I'm going to tell what the answers are if they are, but just for the fun of it. But yeah. All right, Joshua, number 3.
Yes.
Yes, they are. And if you added them, would have gotten negative 13 times the square root of 5. Number 4, Lana.
No.
No. Square root of 14x is not the same as square root of x, even with a 14 in front. The radicands have to be the same, and they weren't. How about number 5, Joshua?
Yes.
Yes, they were identical. We would have gotten 82 times the square root of 3b if we were to add them. We didn't have to. What about number 6, Lana?
No.
Nope. Now, number 7, Joshua.
Yes.
Yes, they don't look like it when they're written this way. But you can't leave them that way, Joshua. You simplified this down to get,
4 times 10.
which gave you,
2 times the square root of 10.
excellent. And this simplified down into,
9 times 10.
which gave you,
3 times the square root of 10.
and sure enough, they're similar. And if you added them, you would get
5 times the square root of 10.
5 times the square root of 10. Great job. How about number 8, Lana?
No.
Actually, yes, but you have to simplify them. If you look at the way they're written, no. And they won't necessarily be like terms, but they can be like radicals. Lana, how would you factor the 8?
2 and 4.
2 times 4, and of course don't lose your x squared, where you'll take the square root of the 4 to get
2.
2, but we'll leave the square root of the 2. But 2 goes into 2 one time with nothing left, right? So we can also take the square root of the x squared to get x. And right here, this actually factors into 2 times 36, which would give us
6.
times the square root of 2. Now I want you to notice, although these are similar radicals, they are not like terms. You notice the letters don't match, right? So you still can't add them together, but they are like radicals. Do you see it now? Okay, question on that? All right, so yeah, on the surface they don't look similar, just as these don't look similar, but they reduce to become similar radicals. Now these are also like terms. These are similar radicals without being like terms. And what about number 9? Back to Lana?
No.
No, a cube root and a 6th root are just not the same thing. So no, not similar. Questions on the 1 through 9? Yes, sir.
On number 8, what
Uh-huh.
happened to the x squared?
You took the square root of x squared
Oh.
to get x. So the x comes out, and that's how they end up being similar to each other. Similar radicals. Again, not similar terms, but similar radicals. All right. Let's take a look at numbers 10 through 12, and you're simply determining are these like terms, and if they are, we add them. Number 10, Lana?
Yes.
So we get?
7x cubed.
Yes, they are like. We get 7x cubed. How about number 11, Josh?
No.
No, so we can't add them at all. How about number 12, Josh?
Yes.
Yes, and we get?
13 CD.
13 CD. Good. Questions on 10, 11, 12. All right, now coming to number 13. Are they like? And now if they're like, they wanted you to actually add them together. They didn't need you to add on 1 through 9. They are having you add here on 13 to 18. What's the verdict on 13, Josh?
Yes.
Yes, they're similar? The square root of 15 and the square root of 4?
Oh, 3 times.
Yeah, this doesn't reduce at all. You say, well, I could factor 15 to 3 times 5, but can you take the square root of either of those?
Yes.
Yeah, now then this would become what? Square root of 4 just becomes 2. So we get the square root of 15 plus 2. One's irrational, one's rational. They're definitely not similar. For redemption, how about number 14, Josh?
Yes.
Yes, they are similar. And what did you get when you added?
6 times the square root of 3.
Good, 6 times the square root of 3. Number 15, Lana?
Yes.
Yes, they are similar. They're both cube roots of 7, and we add to get?
Negative 1 times the cube root of 7.
Good, negative 1 times the cube root of 7. How about number 16, Joshua?
No.
Lana?
Yes.
Lana's like, I got him! Now, they don't look it, do they, Joshua? 4 times the square root of 5 and a negative 7 times the square root of 125. Well, I throw the chalk everywhere. They don't look similar. But Lana, we could factor 125 into
5 and 125. I mean, wait. 5 and 25.
5 times 25. where you can take the square root of the
25
to get
5
5.
times the square root of
There we go. So the square root of 25 becomes this 5, and then this 5 stays right where it is. So we end up getting what right here, Lana?
negative 35 times the square root of 5.
And here we'll keep the 4 times the square root of 5. And when you take 4 square root of 5 minus 35 times the square root of 5, we get?
Negative 33 times the square. That's what I got at the end.
Well, if you have a positive 4 and a negative 35, maybe write it this way, stacked on top of each other so you can see a little bit easier. What's 5 minus 4?
1.
1. And 3 minus nothing is
30.
3. So negative 31 times the square root of 5. So I'm not sure where the
I don't know.
3
I don't know. I do not know what I did on
Okay. Does it make
No,
sense
I
what you
see
should
what I
have did?
did,
You do see
actually.
what you did, okay?
I reduced the 4 times 2 times the square root of 5.
Ah, okay. I did actually wonder if maybe that's what you've done. Lana says, hey, here's a 4. I can take the square root of 4, and she got a 2. The problem is there's not a square root symbol on the 4, so I don't need to take the square root of 4. You see it now? Leave the 4 alone. If it had been the square root of 4 times the square root of 5, then maybe 2 square root of 5. But no square root symbol, don't take the square root. Make sense now? Joshua, questions on this one now? Reducing it down, and lo and behold, yep, they are similar radicals to each other. Let's take a look at the next one. Joshua, number 17.
Yeah.
All right, we got 2 times the square root of 6a, and we've got a square root of 36a. Now, thoughts on one of those two radicals there, Josh?
The 36a.
Yeah, do I need to factor that 36?
No.
No, because I can take the square root. Notice there is a square root this time, Lana. I can take the square root of 36 to get
6a.
plain old 6, but I cannot take the square root of the a.
Yeah.
Here, you can't factor the 6, you can't take the square root of 6, you can't do anything with it. But notice this 6 is still in the radical, because you can't take the square root of 6. This 6 is out of the radical because you did take the square root of the 36.
I thought it was just in the radical 6 and a, so
Does it make sense now? Square root of 36 is not the square root of 6, it's plain old 6 outside the radical, rational 6. And this is an irrational 6. So no, they're not actually similar to each other after all. How about number 18? Back to Joshua.
yeah.
Okay, you sound very very unsure of yourself
I
there.
got an answer.
All right, well let's see what you did then and see if we can confirm or deny allegations of similarity here. How did you reduce the 9 times the cube root of 40b?
9 times the cube root of 8 times 5 would be.
Good. Factor that into 8 times 5 and then keep the b. And you could take the square root of the, or cube root, excuse me. You take the cube root of the
8
to get
9 times 2 times 9 times 2 times the square root of 5 cube root of 5.
There we go, which finishes simplifying into
18 times the cube root of 5b.
all right, and then we take a look at, there it is, the other one, which was the cube root of 135b. Now there is a little hint here, class. Look at what's left in this radical. This radicand says what?
5b.
5b. Wouldn't it be nice if this was something cubed times 5b? Wouldn't that be great? What is 135 going to factor into here, Josh?
27.
Ah, and that's exactly the kind of number I was looking for, because I can take the cube root of that.
To get 1 times 3 times the cube root of 5b.
There we go. Now, we don't have to necessarily write the 1 like he said, but 3 times the cube root of 5b. And I'll just bring that down one more level so it lines up. And what do we get for our answer?
21 times the cube root of 5b.
21 times the cube root of 5b is correct. Great job. Wanda, did you get that also?
I got 21 times the cube root of 5, and then I left the b off.
Does it make sense the b is just kind of along for the ride? Don't lose the b.
So
Questions
technically,
on
I
barely missed it. Okay. Does it make sense now? Joshua, questions on that?
No.
Questions on that? Tell you what, go ahead and clear your desk area except for 2 clean sheets of paper and a pencil. Clear your desk area except for 2 clean sheets of paper and a pencil. I'm going to give you a little 5-question bonus quiz today. We're going to do something a little different. We don't take these very often. I think I've only done one of these all year. So we'll do a little bonus quiz here just to make sure we've got this down really well before we progress. So books aside, just 2 clean sheets of paper out. And you'll count it if you do well, and you won't count it if you don't do well. Well, this will give me a read on how we're doing. One of the sheets of paper, put your first and last name at the top, along with today's date. One of the sheets of paper, the other paper's for a cover sheet, but one of the sheets of paper, first and last name at the top, along with today's date, which is 4/27/21. 4/27/21. Now we'll just call this a quick quiz. Call this a quick quiz. And number down 1 through 5. What number down? 1 through 5. Number 1 is a yes or no. Are those similar radicals? Number 1, yes or no, are those similar radicals? Number 2, also yes or no. Are these similar radicals? Number 2, are these similar radicals? Yes or no? Number 3. Are these similar radicals? Yes or no? Are these similar radicals? Yes or no? Number 4, I want you to add these radicals if possible. If they don't add, of course, you would leave your answer like we did last time. So number 4, take a moment and add these radicals together if possible. And number 5 is going to be the same thing. Add, if possible, those radicals. Take a few moments to work and turn your quiz paper over when you finish. Finished. And Joshua is finished. All right, put your pencils away, take a pen out. Pencils away, pens out. Let you grade your own so you can decide if you want to turn it in for a grade or not. So just get out a pen, and you can sign your name at the bottom as the grader if you'd like, or you can say signed by the smartest, most wonderful person in all the world, or signed by the humblest person in the world, depending on which might be true of you. But anyway, or you just say signed, checked by me. Number 1, yes or no, are these similar radicals? Well, number 1, the answer is no. Okay, they do not have the same radicands. They are not similar. Number 2, are these similar radicals? Yes, They have both the same indexes, both understood 2, and the same radicands, 2. So yes, they are similar. Number 3, are these similar radicals? No. One's a cube root, one's a square root. They do not have the same indices. No, they are not similar. So your first 3 answers should be no, yes, no. For number 4, these are similar. They have the same radicands. They have the same indices. All they're differing in is the coefficients. And you can add those to get 6 times the cube root of x squared. 6 times the cube root of x squared. Number 5, if you added to get the square root of 39, put a sad face with tears. We don't add radicals written like this. We only add similar radicals, but they do reduce down. This one into 2 times the square root of 3, and this one into 3 times the square root of 3, so we can add to get 5 times the square root of 3. 5 times the square root of 3. Now, if you got all 5 questions correct, you get a free easy 100. If you missed one of these, it's a 90, minus 2 is an 80, minus 3 would be a 70, minus 4 would be a 60, which you wouldn't want to count, and minus 5 would be a 0, which you really would not want to count. Joshua, how'd you do? Got 100, as I would expect. We'll count it, and got 100. Okay, I wasn't sure if that started to look sheepish. I'm like, is she telling me she got a 90? She's handed me the paper. She wouldn't count it lower than 90. Also with the 100. Good job, Lana. And Scott, you can send in your quiz if you did well on yours.
Number 4, I almost changed my answer.
Yeah.
Really? Okay.
Yeah, I was about to say, can you really take the cube root of x?
Yeah.
Well, you can't simplify it at all, but yeah. Now, if it were a 4, yeah, 3 goes into 4 once with 1 left, but not with a square. All right, questions on that? All right, turn your textbooks to page 520. Page 520. We're going to talk about a new type of equation today, and it's an equation that has 2 answers. Now, so far, every time we've worked an equation, let's take a look at the ending of the homework, actually, first of all, 19 to 21. Each of these equations, as you solve for d, or you solve for h, or you solve for x, you got one thing, right? That's it. And that's how every equation has been since you first started learning equations in 4th grade. For instance, on number 19 from the homework, Lana, you got d equals 15. If you got anything but 15, it's wrong. Only 15 is the answer. Number 20, Joshua, you should have gotten h was equal to 7. And that's the only answer. Anything else would be wrong. Number 21, Lana, you got
Negative 2/3.
negative 2/3. Anything else would be wrong. And it looks like we got Joshua over there looking at me funny. Let's take a look at this, Josh. We have negative x negative 4 is equal to 5x. Josh, what do we need to do first? I got an x on both sides. That's not okay.
I think I did this.
What should I do?
You just subtract the little x.
We'll get rid of the little x.
Yeah.
Which one's the little one?
The negative 1x.
The negative 1x. How do I get rid of negative 1x?
Positive 1.
And what I do to one side,
And reduce the other.
so that's going to give me what?
Negative 4 equals positive 6.
And then I just need to get the x by itself by,
Like dividing the negative 4 from both sides.
ooh, careful. That wouldn't get the x by itself. What's with the x?
The positive.
The positive 6. I need to get rid of the positive 6. So divide the positive 6. And that's where Lana got the correct answer of negative 2/3. Just be careful with that. Does that make sense?
Yeah.
All right, questions on this? Well, the equations we're going to begin working today are called quadratic equations. You notice that term there. Say that word with me, class. Quadratic equations. Again, quadratic equations. And a quadratic equation is any equation that has x squared as its highest power. If you kind of write that off to the side there, x squared as the highest power. Every equation we've worked so far, we've always just had plain old x's, right? X to the first. As soon as you add in an exponent, you are now going to increase the number of solutions. So if you see there in bold, you'll notice it says pure quadratic equations have 2 solutions. Underline that sentence. Pure quadratic equations have 2 solutions. In fact, technically, every quadratic equation will have 2 solutions, but we're going to wait until next year, Algebra 1, to get into other more involved quadratics. We're going to stay with the pure quadratic equations for now. And it says, consider the equation x squared equals 16. Now, realize that where you see an x class, you can insert the word what, right? Because that's really what x is all about, is what. What squared would equal a 16? 1 squared equals 16? 4. So we know that x would equal 4, correct? Because 4 squared equals 16. But remember I said that a pure quadratic has 2 solutions. There's something else that if you square it will give you 16. -4. When you square it, remember any negative to an even power becomes positive. -4 times itself would equal positive 16. So there are 2 solutions, both +4 and -4. Now to solve a quadratic, we're going to do kind of like what we did here. I asked Josh, what is with the x? And he said +6. I said, so what do we need to do to get the x by itself? Divide away the +6, right? Why did we divide the +6, Josh?
Because the opposite
is
multiplication.
It was being multiplied. So we did the opposite of multiplication, which is division. Well, to solve something like this quadratic, we would have to say, well, what's with the x class? A little square. And what's the opposite of a square? A square root. So we could simply take the square root of both sides. And the square root and the square, remember, cancel, because they're inverses, they're opposites, hence the x. And we know the square root of 16 is 4. At least that's the principal square root, right? But remember I told you there's technically 2 square roots to every number. 1 positive, 1 negative. The most efficient way to write this would be to say that x equals +4. The lazy person in me writes this instead of writing +4 and -4 separately. +-4 means both. This is actually 2 separate numbers, but it's a lazy mathematician's way of doing it, right? So if I were to have, for instance, you see the little equation there. 2x squared +1 is equal to 9. You see that in the little blue shaded box. Well, like any equation, we want to get the x by itself. Notice there are 3 things with the x. There's a 1, there's a square, and there's a 2, right? 3 things with the x. Which is least attached, class? The 1. So we put a -1 on both sides, and that'll give me 2x squared is equal to 8. Now what's least attached? This 2 right here. Because this square is actually part and parcel of what x is. It's actually xx, isn't it? This 2 is less attached, so we will divide the 2 away to get x squared is equal to 4. And then finally we'll get rid of the square by taking the square root. And the square root of x squared, well, those cancel to give me x. And the square root of 4 is 2. At least the principal square root of 4 is 2. But there's another square root, isn't there? The -2. So what we'll say is +-2. And there are both of my answers. Now, if it really bothers you, you can write x equals 2 and -2. You could write that. I don't, because I'm a lazy mathematician. But it means the same thing as +-2. And you see that answer there in the blue box. Yes, ma'am?
So, for every equation, would you have to write
The +-? Yes. On every quadratic equation where you're taking a square root, which would be a pure quadratic like we're doing in this class, you'd have to put the +-, to show both roots. Does that make sense?
I feel like we've seen that sign.
You have. You learned it last year when you talked about square roots. In fact, I think if you flip back to page Nope, they did not have it. They did not have it on page 506, but I think in your textbook last year, you saw that positive negative notation. Look at, if you would, at example 11.4a. Look at example 11.4a with me. And they give you a very basic, pure quadratic equation. X squared equals 121. Notice they took the square root of both sides, and they got x is equal to positive negative 11. Pretty easy. Look at the next example. Here, they had some simplifying to do. They had to start by multiplying the 3 times 10, because we don't want that. We just simplify and make it a 30, right? Then what they did was they subtracted away the 3, because that was less attached to the x squared than the other 3, which was being divided. So they subtracted the 3 to get 27. Then they had to get rid of the divided by 3 by multiplying both sides by 3. And that's where they got x squared equals 81. Are you following so far? Then, now that it's down to just x squared, now take the square root of both sides to get x equals positive and negative 9. Make it sense? Turn the page.
We have to check it.
Yeah.
No, I just do it right the first time so I don't have to check. I'm always just careful. Now, if you get a really weird answer, or it's just not coming out right, that's when I go back and check. But when it works out pretty normally, I'm like, I'm going to assume I didn't screw up. So I don't check as often as some teachers would, but that's because like I say, if you're careful, you can usually assume you're right. Most of the time, you'll be correct. And then you kick yourself if you're not. All right, let's take a look at page 522. And go ahead and do numbers 1 through 6 very quickly. Go ahead and do numbers 1 through 6. Most of these should be very quick and easy. Just remember, positive, negative in your solutions. 1 through 6 there on page 522. Josh was flipping back to that page with all the roots on it. Lana just got to the section where, okay, you can flip back if you want to, Lana, and find that page with all the roots on it. I let Josh do it. I'll let you do it too. Scott's like, I didn't have to flip that. Well, you know what, Scott? I'm proud of you. Good job, Scott. Alana's over there like, whatever, Scott. Now, don't be spiteful. Hey, for what it's worth, Scott, they miss you. They were saying the other day, man, it feels like he's been gone forever. And it's only been, what, a month and a half, 2 months? I know. Feels like forever. We miss you. We hope you're happy over there in Japan, though.
Yeah, I'm not having a run.
Hayden's still bitter you didn't have to do your endurance run.
Yep.
Chalk got stuck. Had to scrape it out. Scott says, awesome.
What?
He didn't really say. Anyway, all right, let's go ahead and take a look at our answers here to numbers 1 through 6. I'm having way too much fun with Scott today. All right, numbers 1 through 6. First one, just take the square root. And what do you get for your answers, Lana?
Positive -7.
X equals positive -7. For the next one, same thing. Just take the square roots, Joshua.
D equals positive -10.
Yeah, sure. On the next one, though, Lana, we had to start by,
Subtracting 11.
and that gave you,
R squared equals 281.
and then you looked it up, and you took the square root of both sides, and you got,
And we got R equals positive -17.
there we go, positive -17. On the next one, Joshua, you,
Divided by 2.
and that gave you,
N squared equals 121.
and then you,
You took the square root of both.
to get,
N equals positive -11.
there we go. On the next one, Lana.
Divide by -3.
Good.
To get N squared equals positive 9.
Which is good, because can you take the square root of a negative, class?
No.
No. What squared ever equals a negative? Nothing. So you can't take the square of the negative, so it's a good thing it came out positive. Continue on.
Then you get N equals positive -3.
Good, when you take the square root of both sides. And then for the last one, Josh, 2 steps, or 3 steps.
You multiply 8 times 4 to get N squared -4 equals 32.
Okay.
And then you add a 4 to both sides to get N squared equals 36. And then you take the square root of both to get N equals positive -6.
There we go, perfect on that. We'll be perfect on all 6. All right, go on to do 7 through 12. 7 through 12. Remember, there's a couple different ways you could take care of that awful looking fraction on number 7. Remember, the quickest way to get rid of a fraction is to multiply by the reciprocal. So we're at 2/3. If we multiply by 3/2, bam, bam, we're down to just j squared. But you have to do the same on the other side. Put the 6 over 1 and multiply by 3/2. Cancel the 2 and 6 to get a 1 and 3. Boom, got yourself a 9. Easy to take the square root of both sides. Continue on.
Multiply by 2/3.
Ah, careful. That wouldn't get rid of a 2/3, would it?
And then I got 2 at the end, positive -2.
Yeah. Question? Make sense? Well, we get rid of the thing that's least attached, which is the negative 3, right? Add a positive 3, then I give us y squared over 7 equals 7. But remember, this is dividing away a 7. What's the opposite of dividing a 7? Multiplying by a 7. And what you do to one side, you have to do to the other. And that'll give me a y squared equals 49, which now we can take the square root to get class. Y equals positive negative 7. Were we good to go on the previous one, number 8?
Yeah, it's just
Positive negative 1?
I was on over.
Okay, let's keep going just very quickly here. We should combine our like terms to get 3s squared. Minus 5 is equal to 7. Then we should, talk me through it here. Add 5 to get 3s squared equals 12. And then divide away the 3 to get
S squared equals 4, and then take the square root to get S equals positive.
There we go. Okay, follow that one through. Now the next one's kind of weird.
Yeah.
I've got an a squared here, and there's an a squared there. Are you allowed to have an a squared on both sides? No. So just like before where I said get rid of the little one, get rid of the little one. Let's get rid of this little a squared by subtracting from both sides. What does that give us?
A squared equals 1.
And then we can just take the square root of both sides to get, well, positive negative 1. Does that make sense now? And then this last one here, what is 58 negative 100 going to simplify to?
negative 42.
Yeah,
Negative 42. Good. Then what?
Subtract 8 from both sides.
Good. Subtract the 8 away from both sides to get negative 2h squared equals
Negative 50.
negative 50. Then
Divide by negative 2.
divide away a negative 2. Get h squared equals,
Positive 25.
and there we go. We're set. Take the square roots we get.
H equals positive negative 5.
And there we go. Your homework this evening is to do page 523. The homework numbers 1 through 11. Page 523. The homework numbers 1 through 11. We'll take a look at that in our next lesson. Have a wonderful rest of your day, and you are dismissed.